Hey everyone, welcome to this explainer. Go ahead and grab a seat, get comfortable, because today we're taking a really intimate, almost fireside journey into one of the absolute most fascinating moments where human psychology collided head-on with artificial intelligence. We're going back to a moment that completely changed how we view machines and, honestly, how we view ourselves. So picture this. It's 1997. The reigning human world chess champion, arguably the greatest player to ever live, is locked in a room staring down a supercomputer. And when the machine finally wins, well, the headlines around the world just started screaming that it was the end of human genius. But I want to offer you a slightly different perspective today. We really shouldn't look at this 1997 chess match as some sci-fi doomsday trope. Instead, it's a profound mental model. It's an incredible blueprint for human problem solving that we absolutely need to decode. To really wrap our heads around this, we're going to look through the lens of what the author of our source newsletter, who we'll just call Papa, refers to as the knowledge paradox. Papa finds it absolutely fascinating that a computer, quietly assessing millions of moves in the dark silence of its memory bank, can actually outsmart a worldwide human expert. It's the ultimate illustration of the fail-fast mindset in action. But here's the secret. The real takeaway? This event wasn't a defeat for humanity at all. It was actually a massive, massive triumph of human resolve.
Okay, let's dive into this. Act 1. The Tinkerer's Mindset.
You see, Deep Blue wasn't just born overnight out of cold, sterile metal. Not even close. It was the result of a deeply human journey of continuous learning. Think about how wisdom gets passed down in a family, right? From a grandfather like Papa Q Bear to Papa, and then maybe onto a spouse like Colonel Debs. Every single generation learns from the last, tinkering, refining, and always pressing for more knowledge. The creation of this chess-playing computer was exactly like that. It was a multi-generational legacy of human tinkers constantly passing the baton to build the ultimate fail-fast engine.
And looking at this timeline, you can clearly see that the machine is really just the accumulation of human scientific history. Back in 1950, Claude Shannon first proposed the theory of a chess search tree. Then, by 1951, Alan Turing was literally handwriting the first chess program. Think about that. Decades later, brilliant scientists like Feng Xiong Hu developed early models like ChipTest, eventually teaming up with IBM to create Deep Thought and finally the famous Deep Blue. The machine that sat across from Garry Kasparov was carrying the heavy legacy of nearly a half-century of human genius.
So, you might be wondering, why did it take so long to pull this off? Well, it all comes down to this number, 10 to the power of 40. That's a 1 with 40 zeros after it. That is the staggering, mind-bending number of possible legal chess moves. It's an unfathomable rising tide of complexity. To beat a world champion, these tinkerers had to somehow tame an entire ocean of possibilities. And this right here brilliantly illustrates exactly how they did it. They had to take subjective human intuition, that gut feeling a grandmaster gets, and translate it into a language of strict, cold logic. They built branching search trees and actually taught the machine to prune away the bad moves to save computing power, basically failing fast. They assigned numerical scores to super abstract concepts like piece mobility. And finally, computer scientists like Murray Campbell sat down with human grandmasters like Joel Benjamin to fine-tune those algorithms. It was this beautiful, unprecedented marriage of human art and machine logic.
Moving right along to Act 2, Tension in New York.
Now let's set the scene. It's May 1997 at the Equitable Center in New York. The atmosphere is just thick with tension. Kasparov had actually beaten an earlier version of Deep Blue the year prior, but IBM spent that entire year turbocharging the machine. What's really interesting here is the sheer contrast between these two opponents. On one side, you have Garry Kasparov, a brilliant, deeply intuitive mind who uses analogy, comparing the current board to past games. He relies heavily on psychological warfare and maintaining his emotional equilibrium. On the other side, Deep Blue. No emotions, no psychology. Just evaluating 200 million positions every single second with relentless, brute force calculation. The match unfolded like a Hollywood script. Kasparov strikes first, taking game 1. But the real turning points, the moments that literally changed the trajectory of computing, happened in game 2 and the fatal game 6. Let's zoom in on game 2. This is where Kasparov's mental fortress was totally breached. Deep Blue played a move, bishop to e4, that was stunningly human. You see, computers were notorious for always grabbing immediate material advantage. But here, Deep Blue prioritized long-term positional strategy instead. Kasparov was just so shocked by this restraint that his psychological collapse began right then and there. Feeling completely outplayed, he resigned.
But here's the tragic irony. Post-game analysis by experts later revealed the position was actually a draw. He resigned a drawn game purely because the machine broke his mental resolve. Crazy, right? Kasparov was completely reeling after that. He even went so far as to accuse IBM of cheating, suspecting that human grandmasters were secretly feeding the computer its moves behind the scenes. Now, looking at this objectively, IBM heavily denied it. The reality is much more likely found in this quote from IBM's CJ Tan. The sophisticated grandmaster tuning the IBM team had done simply disrupted Kasparov's emotional equilibrium. He walked in expecting a predictable machine, but he sat down across from a deeply nuanced opponent. And that emotional disruption completely boiled over in Game 6. The rapid collapse. Desperate to try and jar the machine out of its programming, Kasparov went with a highly unusual anti-computer strategy, using the Caro-Kann opening. But the pressure was just too intense. He made a fatal error, an accidental transposition of his moves, playing h6 instead of bd6. Deep Blue instantly pounced, sacrificing a knight and just completely destroying Kasparov's position. The greatest human player in the world resigned in a mere 19 moves. The climax of this whole man versus machine saga is captured perfectly in Kasparov's own awestruck and maybe even a little fearful realization. He said, "For the first time in the history of mankind, I saw something similar to an artificial intellect." Which brings us to Act 3, the human mirror. Look, Deep Blue wasn't some kind of monster coming to replace us, it was a mirror. It simply reflected the sheer brilliance of human engineering. That 1997 match fundamentally shifted the public conversation forever. We finally stopped asking if computers could beat humans, and we started asking how we could apply this immense parallel processing power to solve the world's most complex problems. And here is exactly why this matters to you and me today. That exact same architecture that the tinkerers built to defeat Kasparov, it's currently fueling massive breakthroughs all across the globe. We use it in finance to rapidly evaluate risk across massive stock portfolios. We use it in data mining to uncover hidden patterns that a human eye would never catch. And honestly, most importantly, we use it in healthcare, analyzing incredibly complex molecular drug interactions to develop life-saving pharmaceuticals in a fraction of the time it used to take. All right, let's wrap this up with our synthesis beyond the board. The chess match was really just the beginning. So what are the big takeaways from this explainer? Well, first, Deep Blue's victory was actually a massive victory for humanity. It was a triumph of generations of programmers, engineers, and tinkerers. Second, that fail-fast algorithmic mindset, the ability to test millions of paths and instantly discard the bad ones, is the absolute key to decoding impossible complex systems. And finally, chess was never the end goal. It was simply the ultimate test track for the world-changing problem-solving technology we rely on today. The machine is a tool serving human ends, for sure, not replacing human value. Which brings us full circle, right back to the wisdom that sparked this whole explainer. Papa's take. Technology does not and should not ever stop humanity's resolve to learn continuously. Whether it's a grandfather passing down wisdom or a team of scientists building a supercomputer, our innate drive to press for more knowledge remains our greatest asset. So, I'm going to leave you with this final thought. We've seen what happens when humans spend decades applying the tinkerer's mindset to a problem with 10 to the power of 40 possibilities. It's incredible. So look at the complexities in your own life, your own work, your own passions. How will you use the tinkerer's mindset to fail fast, learn continuously, and press for more knowledge today? Keep exploring, stay curious, and I'll catch you in the next explainer.